And by the end of mesosphere, can you see that almost the temperature is reaching minus 90 degrees Celsius. In fact, we will see that mesosphere is the coldest layer of classified. The structure of the atmosphere can be classified in number of ways, on number of bases. So that is what we are going to study here. So we are saying that when we are talking about the structure of the atmosphere, the classification can be, in fact, we can talk about three types of classification. And if I talk about these three types of classification, one we have already talked about little bit, I'll also just mention about that. So one is on the basis of composition. So we have already seen this classification, if you remember, on the basis of composition in the composition of atmosphere topic. And what we saw in this, if you remember well, we saw that the atmosphere could be divided into two major layers. Up to the height of 80 kilometers, we were calling this part as the homosphere. Then beyond this lied the heterosphere. And we saw even within heterosphere, there were layers which were forming. So lowest layer was made up of nitrogen. Then there was atomic oxygen. Then if you talk about, it is helium. And then if you remember, we talked about hydrogen, which is the lightest of all these three. So based on their molecular weight, atomic weight, if you talk about, this is the sequence of those layers which are present, which form the part of the heterosphere. If you remember, we saw in the homosphere, there was a fixed composition of the dry air that we talked about. You remember the concept of dry air that we talked about? So there is a fixed composition. Now, one question that comes to my mind here is, why there is like a fixed composition in the homosphere and not so much like fixed composition in the heterosphere? Actually, the answer lies in the fact that homosphere can be called as the lower frictional layer of the atmosphere, where there is some friction still of the earth. And in fact, this is the layer where lots of atmospheric movement is taking place. So because of it being a frictional layer and characterized by presence of atmospheric movement, what is happening within the homosphere is that there is lots of mixing taking place. And because of this mixing of the air, here the air is much more well mixed. And ultimately, as a result of this, what we find that here in the homosphere, there is more or less fixed composition within the dry air. Although, if you remember, we talked about that dry air is a more theoretical conception, there are also lots of variable components which are present in the homosphere. If we go above homosphere, then such kind of movement is not found, such kind of mixing is not found. As a result, here the components of the air, these gases arrange themselves into according to their molecular weight, and the heaviest is nitrogen, thus it is found at the lower part of the heterosphere, then it is oxygen, then it is helium, and then it is hydrogen. So this is one type of study of the structure of atmosphere which is based upon the composition. Then there can be others as well. For example, if we talk about, it can also be on the basis of atmospheric pressure. So we can classify the basis, the second basis can be the basis of atmospheric pressure. And if we talk about, you must be aware that at average sea level height, we take that as the base pressure. Here the pressure is around 14.7 pounds per square inch, which is in turn equivalent to about 1013 millibars, MB. MB here will later use lots of this term MB, and we will see MB is basically what it is, millibars. So that is the atmospheric pressure which is found at the sea level. Now if we go upwards from here, what we will be finding with altitude, the pressure, the atmospheric pressure will be declining. Can you see at 0 kilometer, that is the sea level, the atmospheric pressure is this much, 1013. But at 1 kilometer it becomes almost 900. Then at 2 kilometer you can see that further decline, 3 kilometer further decline, and so on. So very clearly what is happening, can you see the pressure, atmospheric pressure is declining very sharply as you move upwards in the atmosphere, and this can be displayed by this graph. Can you see here on in this graph, this is altitude in kilometers, and as you are going upwards, can you see at the sea level there is higher pressure, and as we are going upwards, what we find, the pressure is declining at very fast rate. In fact, can you see that almost beyond 20 kilometers, how much fast rate of decline is taking place? Can you see that? And here we are just taking up to 40 kilometers. Hardly this means that in fact what we find up to 80 kilometers, that is, if you remember, that was the homosphere. Beyond the boundary of homosphere, only 1% of the atmosphere lies. That means 99% of the atmosphere actually lies within the homosphere. So that is basically what? That is the distribution, that is the classification of the structure of the atmosphere on the basis of essentially pressure. Now, one thing that comes to my mind, why this kind of distribution of pressure? So the answer is very simple. One thing you can understand, that atmosphere is essentially a gaseous component, but it would be affected by the pressure which is above it. So suppose I am talking about the atmosphere, and tell me, can we say if there is this one layer, lower layer, layer A, can we say that this much of atmosphere is superimposed over this layer A? So can we say that because of this superincumbent load, what will happen? It will be compressed. And as a result of this compression, what will happen? Here the atmospheric pressure would be the highest. Then as you go in the above layer, here can you see this much is there. So here in this layer what we are finding, there is less superincumbent load. Then if I go to layer this, there is less superincumbent load. Here it is very less superincumbent load. So can you see above A there is weight of B, C and D. So there is maximum pressure over A, maximum compression of A. So here atmospheric pressure will be highest. When I go to B layer, there is superimposition of the weight of C and D. That means lesser than A. That means the compression will be lesser than A. So here there will be pressure, atmospheric pressure greater than C but less than A, and likewise. So this is how the atmospheric pressure is distributed. So the second classification basis is essentially what? It is the atmospheric pressure. But the most familiar one, which you would have also read in your school times, is the one which we base it on the basis of temperature distribution in the atmosphere. So the third classification is on the basis of temperature, or better say vertical temperature distribution. Vertical temperature distribution. So that is the third, and this is one, you know, the most important one which we use. So if we talk about this phenomena, can you see how vertically the thermal structure of the atmosphere is found. Can you see that? This is how the thermal structure of the atmosphere is essentially found to be. And you must be aware that if I talk about these layers, so for example, we find that from about 8 to almost 18 kilometers. So 8 to 18 kilometers, we find that there is here troposphere. In fact, the boundary of the troposphere is what we call it as the tropopause. Then if you talk about the height, here not that much high. So this is basically, this lower layer is what it is, the tropopause, and above this layer lies what we call it as, can you see, what we are calling it as the stratosphere. Now above this stratosphere, around this height of 80 kilometers, can you see that how the temperature is changing? This layer is your mesosphere. And beyond this 80 kilometers, if you remember, that was our heterosphere, this entire layer is what we call it as the thermosphere. We will see that in fact this thermosphere is further divided into two parts, and it is actually up to 300 kilometers it can be found. So I am just writing it here because it is not given there. So up to around 300 kilometers, you will be finding that there is what we call it as the ionosphere. So ionosphere is actually what? It is part of the thermosphere. It is the lower part of the thermosphere, and beyond ionosphere lies what we call it as the exosphere. So we'll see that on what basis the thermosphere is divided into exosphere and ionosphere. But can you understand this basis of division, which is the most popular division into troposphere, stratosphere, mesosphere and thermosphere? It is essentially based upon what? It is based upon the temperature distribution. It is very clear from this diagram that within the troposphere there is decline, sharp decline in the temperature is taking place. Then along the tropopause and lower stratosphere, what we find, there exists some isothermal condition, that means the temperature is not changing. Can you see along tropopause, somewhere around minus 60, minus 70 degrees Celsius temperature is reached. More or less around minus 60 degrees Celsius temperature is reached. But within the stratosphere, can you see there is increase of temperature taking place. Again, at the boundary of stratosphere lies your stratopause, is the boundary of stratosphere with mesosphere. So here can you see again an isothermal, that means no change, layer is found, and then again in the mesosphere temperature begins to decline. And by the end of mesosphere, can you see that almost the temperature is reaching minus 90 degrees Celsius. In fact, we will see that mesosphere is the coldest layer of the atmosphere. Then again beyond mesosphere, again some isothermal conditions, then again continuous rise in the temperature in the thermosphere is taking place. So on the basis of this temperature distribution, what we can do, we can divide the atmosphere into these four major layers. I hope it is clear to you.